Okay, continuing on here. Number 2. These are all long and slow. So the way you can do this is you can solve them independently. So we'll start with this one. And if I subtract 4 from both sides, I get smaller or equals to 0. And there we go, just throw in a 0 like that. And then to get 4 over x plus 3, I have to multiply it by 4 times x plus 3 over x plus 3. And that'll make them both over the same denominator, which means I only have to write one of them. You now have a fraction over the same denominator. When I put this through, I get this. And of course, I get 2x plus 12 is smaller or equal to 0. Now, before I do that, by the way, you can take a 2 out of it as well. And you get x plus 6. Now, before I do that, let's look at the other one. Hang on. When I expand that, sorry, it's the minus 4, 6x, minus 4 times the x plus 3. You get 2x minus 12. And of course, if I take the 2 out of it, it's x minus 6 over x plus 3. Now, before we solve that, it's a lot easier just to look at the second one and realize it's the same thing. So you can see that you can have two very different fractions or mixed fractions that represent the whole fraction. But it's almost impossible to see until you put that over x plus 3. But now that you have the same equations, they automatically will follow the same rules. So there's no real need to solve it. Now, yeah, I could sketch the solution on a number line. Obviously, this will be below 0 or equal to 0 at 0. So one of the solutions is when x is equal to 6, it'll be 0. And then whenever this is minus and this is plus, or vice versa, it will be below 0. So you would just do this as a number line. You have the whole thing. Try to remember we're trying to get below or equals to 0. You have this as an individual. You have this as an individual. You do this, you make a box, and of course we're dealing with plus 6 to the left of it, and to the left of minus 3. You're going to do it this way. And you're just going to see when it comes out as negative here. Then it'll be below 0. So we're going to use negative 3 and positive 6. So we're going to take a number less than negative 3, so negative 4. At negative 4, this is negative, and this is negative. So this comes out positive. At 3, it's an asymptote. So we're going to skip that. Between negative 3 and 6, 0 is a good one. So this is positive, and this is negative, which makes us negative. And 6 is included, because if you put 6 in there, you get 0, and we're trying to do smaller equals to 0. And then anything to the right of 6, let's say 7, this is positive, which makes positive, which means this is the only range where it works, and you would write it like this. Minus 3 is smaller than x, smaller or equal to 6, because 6 is included, or you could do it in, I think it is in rounded brackets, minus 3 comma 6 in curly brackets, means the 6 is included, is another way of doing it. That's interval notation, which is this one right here. So the round bracket means the minus 3 is not included, and the curly bracket means the 6 is included. Okay, moving on. You see a lot of these are the similar things, similar questions. Some of them are trying to make it easy on you. Some of them I'm not going to go through the full process, because the full process is the same thing over and over again. So we need to prove that this is the same as this. So this is already in a mixed fraction, so let's just focus on this one. And there's no y there. So our first step is to subtract this. and make it bigger than 0. And clearly the only way to make it over x is I have to multiply this by x over x, which is multiplying it by 1. So I get x squared. And this one, when I multiply by x over x, I get x. And now it's all over x. You can change any number if you multiply it by 1, and x over x is 1. So now if I look carefully at the top, that factors out into plus 5 x minus 3 over x. And we can see right away it's the exact same as the second one. Okay, so there's that. Now we're going to use a table like we did before. So we do the whole thing like this, and then we do individual lines like that. Push this over here. And we figure out the limits of our table. So we're going to make it 4 down like that. We're going to make it like this, like this, like this, like this, like this, and like this. So if we look at the limits, it's minus 5, 0, and 3. So a number left to minus 5, minus 6. And we're trying to come out as a positive number. So minus 6 makes this minus, minus, positive. No, wait. Minus, minus, minus. So we get minus, minus, minus. If I multiply minus times a minus times a minus, I get a minus. So that's a big old no. Then between minus 5 and 0, let's take minus 1. I get positive, negative, negative. So I get positive, negative, negative. If I multiply all those together, I get a positive number. Then from the 0 to 3, I will take 1. I get positive, negative, positive, positive, negative, positive, which, if I multiply them all together, makes a negative number. And I'm willing to bet to the right of 3, I'm going to get the thing I want. So 4, we get 9, positive, positive, positive. So we get all positive, which is above 0 if I multiply them, which means that's it. This means this is our range. For minus 5 smaller than x smaller than 0, but also x bigger than 3. In notation, it's kind of hard. It would be round brackets, minus 5 comma 0. And then from here, it's 3 comma infinity, both round brackets. Infinity always has a round bracket. And it would have to be or, the word or in there. Pardon me. So that's how you do that one. And they're all like this. I'm not going to verify using graphic technology. Just pull out your Desmos and do it yourself. Okay, we're going to put the minus 2 on this side. And if I multiply minus 2 by x plus 5, oh yeah, that's a 0 on the right side now. Bigger than 0, so we're looking for positive. And if I take a minus 1 over x, 1 over x plus 5, and I subtract 2 times x plus 5 over x plus 5, that's how I get the 2 over that. It's all now over x plus 5. I get minus 2x minus 10. Or, yeah, it should be minus 10. Or minus 2x minus 9. And if I take the minus out, I get 2x plus 9. But, yeah. Yeah, I don't know if it's worth taking the minus out. Let's just leave the minus in. There. When is this above 0? When both the top and the bottom are negative, or both when the top and the bottom are are positive, and this is how you do all of them. Okay, so I mean, I don't think I'm going to do them all. I think I'll try to solve them all. So you got to figure out when this is positive or negative, when this is positive or negative, and then conclude if this comes out positive or negative. And you've got to figure out where your boundaries are based by making any of those equal to 0. So if the first one's equal to 0, we're talking 9 divided by 2 by negative 2. So we're talking about negative 4.5. And we're talking negative 5. So really negative 4.5 should be here because it's to the right of negative 5. And you can see that this space is hard to find because we're using 4 point and negative 5. But let's start with to the left of negative 5. A negative 5 here makes negative 10, but it becomes positive 10 minus 9 is positive. A negative 6, actually, I got to take more than, so we'll take negative 6. Negative 6 here makes negative 12, then becomes positive 12, minus 9 is 3, so it becomes positive. Negative 6 here becomes a negative. When I multiply a negative and a positive, I get a negative. That is not bigger than 0. So that's a big old no. Between minus 5 and minus 4.5, let's take minus 4.7. Minus 4.7 times 2 is negative 9.4. With the negative in front, it becomes positive. Minus 9 becomes positive. With a negative 4.7, this becomes positive, and we get that. And then, of course, it's going to be anything above negative 5. Let's take 0. We get minus, positive, and so it will become minus. So the only one that works is between negative 5 and negative 4.5. So that would be written like this. Round brackets because it's bigger than 0. Or negative 5 smaller than x, smaller than negative 4.5. All right, moving on. From now on, I think I'm just going to solve the equation, and then the inequalities are the same way each time. So put this over here. We're going to subtract it. It's going to be smaller than 0. So we've got to cross multiply, really. This has to be multiplied by x plus 3. And this has to be multiplied by 2x plus 10 over 2x plus 10. And then you'll have it over the same denominator. So you can just leave the denominators unexpanded, and it's all going to be over that. You can verify if I got that right. Pretty sure I did. But this minus applies to everything in the bracket, so I can get minus x minus 2x and 3 minus 10. I'm going to get minus x minus 7. And then you just do the number line. Now it's got to be smaller than 0, so this whole thing has to come out negative. I'll let you do the number line. I'm going to stop doing the number lines. It's just not worth it. Here we have to subtract this from both sides. And we essentially have to cross multiply. So you get minus 3x and then minus 4. Put that all in brackets times x minus 2. So you get 3x minus 4x plus 8, all of it over x minus 2 times x, and it's all smaller than 0. I forgot to make the right side smaller than 0. And then if I look at this, it becomes minus x over 8. So you have to make all three of those things, the minus x plus 8, equal to smaller than 0. So they all have to come out negative. Here's the same thing. There's an equal signs in this one, so you have to be careful. You bring it to this side. Make it bigger than 0. cross multiply. To get it over the same fraction. You're really multiplying it by x plus 4 over x plus 4. That's just to get it over the same fraction. So you're left with 7x times plus 4, which is 7x, plus 28, minus 2x plus 6. That's what happens when you take minus 2 multiplied by x plus 3, all over x minus 3 and x plus 4. And 7x minus 2x is 5x, 28 plus 6 is 34. So the number you're looking for up above is minus 34 over 5, 3, and minus 4. This is roughly 7. I might have gotten the 34 wrong, but it doesn't matter. It's the same process over and over again. Again, subtract this from both sides. And cross multiply. You're not really cross multiplying. You're multiplying by x plus 4 over x plus 4 and x minus 3 over x minus 3, but I'm just saving time because they end up over the same denominator, and there's no point in me doing it over and over and over again. It's not really cross multiplying. So on the left, I end up with 7x plus 28. And on the right, I end up with minus 2x plus 6 all over x minus 3, x plus 4, and 7x minus 2x, 5x, 28 plus 6, 34. Oh, I think I already did that one. Sorry. Yeah, I did. Sleep at the wheel. And then this one. So same thing. Subtract from both sides. It's going to be equal to 0. So it's a cross multiplication. Not really. I'm multiplying this right one by x plus 1 over x plus 1. There's no point in doing it twice. And I'm multiplying this other one by x. So I get minus 6x minus x minus 1. So minus 7x minus 1. All over x plus 1 and x. And then you solve with the number line. And the last one. Get rid of the rest of it. Bring it all to the left side. Smaller than 0. Minus. And you have to multiply this by x plus 4. And this by x plus 1. See, on top you get minus 5. Minus 5x minus 5. Minus 3x plus 12 all over x minus 4, x plus 1. And you get minus 8x plus 7. And that's that one. And they keep testing you over and over and over again. So really, these are figuring out the factors. That's what they're testing you on in number 5. They're making sure you can still factor. So if you look at the top, it's 4 and 3. A number that adds up or multiplies out to minus 12 and adds up to minus 1 is negative 4 and plus 3. So up top you get t minus 4, t plus 3, and you can always expand it to make sure. And those are the three x's. You've got to figure out a number that goes from minus 3 is the border, 1 and 4. And those are the borders you use to see if all of that comes out as, since it's smaller than 0, all of that has to come out as negative. Here, what's a number that multiplies out to minus 6 but adds up to plus 1? We're talking about plus 3 and minus 2. All over t minus 4. Same thing. It's all got to be, this time it's bigger or equal to 0. So the top can be exactly at minus 3 and exactly at 2. The bottom is irrelevant for the equals to 0. This one we have to come up with a number that multiplies out to 6 but adds up to minus 5. So we're talking about, that's a good one, plus 6 but minus 5. So that means they have to be two negative numbers. So we're talking about x minus 2, x minus 3. But now we have to divide them both by the front number to do the slip and slide. This simplifies to 1 over 2. This simplifies to 1 over 3, which means this 3 slips in front, and this 2 slips in front. And always verify with this method, and it should be a t. So you've got 6t squared minus 3t minus 2t plus 1. Got it. And 2t plus 1. And that means the borders we're looking for are a third, a half, and negative a half. Now they're making you put it on both sides first. They're making you do extra work here. That means I have to put this over 5t by multiplying by 5t over 5t. And when I do that, I get 5t squared minus 5t minus 30 all over 5t. Now, I have to come up with a number that multiplies out to minus 5 times minus 30, minus 150, but adds up to minus 5. So they're going to be very close together. 3 and 50 is not close together. So we're talking about like close to the square root. Close to the square root of this is 12. So we're talking about 10 and 15. Yeah, looks like 10 minus 10 minus 15 positive 10. So doing the slip and slide, we've got t minus 10, t plus t plus 10, t minus 15, t plus 10. Divide them both by 5. You get a 3 and a 2. But that won't work because we have to come up with a 5. So we can try this, 5 and 10. And we'll try that. 5t squared plus 10t minus 15t, that's minus 5t, minus 30. There you go. That works. Sometimes the slip and slide doesn't work properly, so you have to just readjust a little bit. And the number, I won't bother with the numbers we're looking for. The same thing, they're making you do both moving to the left and factoring. We're going to do this. It's got to be put over t. So we've got to do t over t. So you get 2t on the left minus 10. Let's put the minus in front of the t, so you get minus t squared minus 5t. Been talking about negative 3t total. Negative 10 we'll put over here. And we'll just take a negative out of it to make everything easier. This one I might want to do again because I don't think I got it right. Yeah, I'm sure I didn't get it right, so let's try that again. So it's 2t minus 10 on the left, and on the right, I get minus t squared minus 5t. Okay, so that makes minus 3t total. And the minus 10 can go at the end. And then when I factor out a minus, I get minus 1 times t squared plus 3t plus 10. A number that multiplies out to 10 and adds up to positive 3 is not solvable. So you'd have to take, and it's all over t, so you'd have to take a quadratic. And you've got to put in 1 for A, 3 for B, and 10 for C, and then we get non-possible answers. So I think either that one's not solvable or I did it incorrectly. And then the last one, and I have to pause after this, subtract this from both sides. It's bigger than 0 now. Cross multiply. Get minus t squared plus 9t minus 8t plus 2. And so that becomes just plus t all over 4t minus 1. And the top and we got 1, 1, and 2, which I don't think is solvable either. Yeah, imaginary number. So I'm either factoring wrong or whatever, but you can go ahead and do it. There's no factors for the top. You can always solve the top as a whole entity and just use the bottom as the factor. So for instance, for this, if this didn't have a solution down here, like that, the top does not have possible solutions. You make a table. Well, first of all, you have to remember if you're smaller than 0. We're bigger and equal to 0. So you got to make a table. And since the top doesn't have a factor, you just treat it as 1. And this, if it's equal to 0, is 1/4. So you're just using this 1/4 as a border. So to the left of 1/4 is 0. When it's 0 here, this is 0, 0. This is positive. And when this is 0, it's negative. So the whole thing will multiply out to negative. And then when it's to the right of a quarter, like 1, you get minus 1 plus 2. That's positive. And you get minus 4 minus 1, which is negative. So you get positive, negative again, which is negative. So if you look at it, both are negative. It's got to be bigger than 0, so it's never bigger than 0. Just to confirm this, I'm going to pull out the Desmos, and I'm going to put minus t squared plus t plus 2, and it's all going to be over 4t minus 1. Let's just use x because it gets confused with non. Oh, no, there's some negatives. And there's some positives, so I did something wrong. Yeah, so I didn't factor it correctly. Oh, it's a minus 1. I put in a 1. There we go. Yeah, I put in a 1. Yeah, to make that easier, yeah, it does have 2 solutions. To make that easier, I should have factored out the negative, so that's my bad. when I factor out the negative, I get t squared minus t minus 2, and it's clear now that that's x minus 2, x plus 1, and there's a negative 1 in front. So you have to include that negative 1, all over 4t minus 1. So I'll do this one for you. And who knows, the last one I might have made a mistake too. So this is what we're using here. I'm going to make a copy. And it's all got to be bigger or equal to 0, I think. Let's go to the textbook for that. Textbook says bigger or equal to 0, yeah. Okay, so we're going to use that. Then figure out when it's bigger or equal to 0. And we make a table like this time. Use the minus 1 as one of them. X minus 2 is another. X plus 1 is the other. 4t or 4x, doesn't matter if it's t or x. And then the whole thing down below. Now you make a table, and there's going to be a whole bunch of things. There's only 3 things. So it's when x is 2, a quarter, or 1. No, or minus 1. No, minus 1 here will always be minus. So let's just put that in there over and over again. Okay. And this will be below minus 1. Let's take minus 2. We get a minus. Get a minus. And we get a minus 2 minus. So we multiply all those out. That's a positive. So that's yes. Now my guess is going to flip back and forth. So between minus 1 and a quarter is 0. So this is a minus. This is a plus. And this is a minus. And if we multiply that out, it goes minus. So I'm quite sure if I just skip, that's going to go plus and then minus again. Because it's equal to 0, you would figure out which one's at the bottom, so the quarter's never included. But this is, and this is. So it's x is smaller or equal to minus 1, or a quarter is smaller to x, which is smaller or equal to 2. Because it has to be bigger or equal to 0, and these are the zones where it's bigger or equal to 0. Okay, I got to pause. Now, 6 says use graphing technology here. And I would strongly recommend Desmos. But instead of writing it as is, which will just give you 2 solid lines, write one equation, like that. Then write the other equation. Got to use brackets, like that. And then they're asking, when is this left one, the red one, bigger or equal to the blue one? So graphing wise, you can see that the red over here is never going to cross the blue, so it's never above, until past this asymptote. So let's look at the asymptote. The asymptote for the blue line is there, and it's at this point, at minus 6, that the red line crosses over and is above, all the way to this point, minus 1, and then all the way to the red's asymptote. Red's asymptote is here. So that means from here, minus 6 to minus 1, it's above or equal to the blue line, and then just past 4. So from 4, and let's see if it crosses on the right, 4 to infinity, it looks like, it is above the blue line again. So just between this narrow space here and from the asymptote 4, x bigger than 4. And you can't say bigger than or equal to 4 because the red line never crosses the asymptote. So it's between minus 6 smaller or equal to x smaller than or equal to minus 1 and x bigger than 4. If you write it the way they have it, all you will see is the block of red represents where it's above, but it doesn't quite tell you, if it's equal. See, it stops there, and really, yeah, it goes from there to there. So it stops there. It says from here to there, where apparently it's crossing, right, at minus 1. And from the asymptote onwards. So, but it only shows you these blocks. It doesn't quite show you a clear picture, which is why I like having it like this instead. So you can see exactly when the red line is above the blue line. It also all depends on their asymptotes. So I'll leave the other ones for you to graph. You don't need me to graph them. This one's going to produce a quadratic, this number 7. So let's see what happens here. So if we first get it all onto the left side, so let's do that. I'm going to do it like this. And we're going to have a minus there. And it's going to be 0 here. So bigger than 0. So to get these on the same denominator, I have to multiply by this one over this, like that. And I have to multiply this one by this over this. And that way it'll be over the same denominator. So if I multiply these first ones here, I get 3x squared minus 8x plus 3x minus 8. So I'll write that down. 3x squared minus 8x plus 3x minus 8. All minus, and in brackets, 2x squared. Give me a bit more room here. Minus x, minus 6x, so minus 7x, and then plus 4. Now all that gets treated by the minus, so all the signs in here change. And then I can see minus 8 minus 4. I can see 3x squared minus 2x squared. And I can see minus 5x plus 7x. X plus 2x. And then I can see if that has a solution, what multiplies out to minus 12 and adds up to plus 2. So it's 4, and now it's not 4 and 3. It's not 6 and 2. It's none of them, I think. Minus 12, yeah, minus 4 plus 3 does not work. So you always want to go back and make sure of your numbers. There we go. So 3x squared minus 8x plus 3x is minus 5x minus 8. There we go. And then over here, it's 2x squared, all in minus. 2x squared minus x minus 6x, so minus 7x. And then plus 4. And then when the minus goes through it, I get minus, plus, minus. Now let's see if that fixes it. So minus x plus 7x is minus 5x plus 7x is plus 2x. Minus 4x minus 8 minus 4 is this. And 3x squared minus 2x squared is this. So I had it right. So this, I'm going to use the quadratic equation, see if there's a solution. And I get 1 is A, 2 is B, minus 12 is C. And I get decimal answers. These are the possible solutions right here. Which is essentially like saying on the top, it's like saying x minus 2.6055 x plus 4.6055, all divided by x plus 1 and 2x minus 1. Now, this has multiple solutions, so you have to make a big thing like that. You have to put the whole thing down below. And you have to put the individual things up here. Makes it very difficult. And then you have to create your number lines. And one of them's over here. And one of them's over here. And then minus 1 is here. And 1/2 is here. So then I draw the number lines like this, and we're looking for anything that's bigger than 0, so it's got to come out as positive. So if I look to the left of this at minus 10, let's say, this is negative, this is negative, this is negative, this is negative. So we get negative, 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 which makes this positive. So that's yes. Then between minus 4 and minus 1, we'll do minus 2. This is positive. This is negative. This is negative. This is negative, which makes it negative. So that's no good. And then from minus 1 to halves is 0, which makes this positive. This negative. This positive. And this negative, which makes it positive. And then it's going to go no again. So between 1/2 and 2.6 is 1, which makes positive, negative, positive, positive, which makes negative. So that's a no. This last one should be a yes. So let's take a 3. That's positive, 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 positive. And that's a yes. So below minus 4.6, between minus 1.5 and above 2.6. It would be infinity minus, I'm not going to do the full number, minus 4.6, minus 1 comma a half, and 2.6 comma infinity. Or it would be x smaller than minus 4.6, minus 1 smaller, or minus 1 smaller than x, smaller than a half, or x bigger than 2.6. They're all pretty much, all these solutions are the same over and over again. Use the graphing technology, verify your answer. Can these rational expressions be used to model real world situation? Almost always yes to C. Equation models the bacterial count. Models the bacterial count in sampled pond water. So we'll see which one passes which. So we'll try a couple of these. Do 8 and 9. So I'm going to make this a big minus in front of it. I know it's got a minus 30 in front of it already. Should be positive. And yeah, we might as well just make that positive right away. Do that. Okay, so we're going to, since they're both over the same denominator, we can do minus 6t plus 30 over t minus 2 is smaller than 0. You can see that there's going to be, if I take the minus 6 out of the top, get minus t minus 5. So we can see that those are the two criteria. There's going to be vertical asymptote with x is equal to 2, and there's going to be a x-intercept at 5, 0. So if we make a table here, we put these terms at the end. And then I just put the -6 as a separate one. And then this whole thing is down at the bottom. Then I only have 2 above 5. And above 2. So 5 and 2. And this is always going to be negative for -6. And so below 2 would be 0. This is negative. This is negative. 5. This would be positive. So that's going to come out negative, which is below 0. So that's a yes. Negative 2 between 2 and 5 is 3. Negative. Negative. Positive. 3 minus 2 positive. So this is going to come out as positive, which is not below 0. And this last one's probably going to come out as negative. So 6. So negative, positive, positive. 6 minus 1, negative. So this comes out as positive. Oh, that's interesting. Let's try that again. Negative. So 6. Positive, positive. 6 will be 1 times negative. Comes out as positive. Yeah, that makes sense. Yes. No, that doesn't make sense. Check the second last one again. For 0, negative, negative, negative. Oh yeah, I made a mistake right there. For 0, it's negative, 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 positive, which comes out as positive, negative, which is yes. So let's check this one again for, oh yeah, that's not 0. That's 3. So I'm going to check out 3. 3 would be negative, negative, positive, positive, which is going to come out positive, which doesn't work. Now this is the weird one here. -6. So negative. I'm going to take 6 here. That comes out as positive, positive, and negative. So that comes out as positive. So it goes negative, positive, positive. So it looks like anything less than 2. Which is odd. I don't know why it would. Maybe it's because it's over the same denominator. I'd like to see a graph of that, actually. So we're going to do -6t over, let's do x over x minus 2, and -30 over x minus 2. And let's have a look. And we're looking for when red line is below, oh sorry, blue line is below, no, red line is below blue line. So that's here until they cross. Do they cross? No, they never cross. So it's everywhere to the left. And just from there, 5 onwards. So just beneath there it doesn't, but just there it's below. So that's where I made a mistake somewhere. That's below here, and it's below there. So I'd have to just go back and check why I made a mistake there. Interesting mistake. This one is clearly a model of bacteria count in a tap water versus a pond. And let's see if we can break down the first one and say, okay, this t squared plus 3t plus 1 is t plus 2, t plus 1, all over 5t. And then the other one, doesn't have a factorable thing down here. You cannot factor a positive. It doesn't have a solution. So essentially, this will always be positive, and this will be negative when t is negative. But when t, which is time, is positive, it's going to be positive. And if we substitute in like 1,000,000 for t here, this bottom's going to be there like this. So you're going to look at something like this. There's going to be the asymptote. And what happens at 0? It goes through 0, comma 0. Goes like this. So you're going to see in a green line, you're going to see, let's try 1, 15 over 10, which is 1.5. So you're going to see this, and then it's going to hump back down. And then for this one, at t minus 2, which is here, and t minus 1, which is here, you're going to see an asymptote. So we're really only concerned about anything after the 1 for this. So let's take 0. So 0 over whatever. So it's also going to start at 0, comma 0. We'll do blue. And let's take 1. We get 5 over 3 times 2, 5, 1. So there's going to be less here, and then it's going to decline. You only have to see if the tap water will ever cross the pond water. So we can make it equals to one another to see if they ever cross. We can subtract from both sides. That. It's going to, when is it equal? And actually, you know what? Let's just do it this way. We can cross multiply. So on the left, we're going to get 5t cubed plus 45t. And on the right, we're going to get 15t times t squared plus 3t plus 2. And we're going to get 15t cubed times 45t squared plus 30t. And when we subtract the 15, is that 15t squared? It's t cubed? Yeah, it is. When we subtract the 5t cubed from the right side, we get 10. When we subtract the 45t, we get minus 15. When we take a t out, we get 10t squared plus 45t minus 15. And when we subtract a 5 out, we get 2, 9, and 3. So we have to ask ourselves something that multiplies out to minus 6 and adds up to 9. Not really feasible. So what I'm going to do is I'm going to take the original ones like that, just in case. I'm going to take 10 as A. And this is just to see if they ever cross. 45 is that, minus 15 is that. And they do cross. They cross at 0.311 and minus 4. So only the 0.311 matters. Which means that red at some point is slightly above the pond water till here, and then it's below. Right there, 0.311. Let's see a graph of this and see if that's true. We're going to take the pond water as a separate, the tap water as a separate equation. And I'm going to make it x instead of t because Desmos doesn't handle t too well. And then I'm going to take 15x divided by x squared plus 9. And here's what it looks like. And sure enough, right there is the only time the tap water is above the pond water till it crosses there. Then it stays below it forever. On the left, it crosses as well right here. That's where the minus came from, but we don't concern ourselves with negative time. So the only thing that matters is when x is bigger or equal to 0. When x is bigger or equal to 0. These are the only periods that matter. So right there, that's the only time the tap water is above the pond water. So the answer would be between 0 and 0.312. And if it says smaller equals, yeah. So there's our answer, between 0 and 3.1999. Will it be bigger than 0? So very straightforward question. You just got to map it out. Consider the inequality. Rewrite the inequality so there's a single simplified expression on one side. Then an economist looks at revenue versus costs. And then he has a profit model. Explain why this and this are equivalent. Okay. So 10 we just got out. I'm just going to put it on one side. I'm not going to do anything else other than that. So if I put this all on one side, this becomes a minus on the left. And 0. And then to put it all over the same thing, I have to multiply everything by 2x over 2x. So I get x squared minus 4x. And that just stays as minus 5 all over 2x. Smaller than 0. If I solve the above equation, I get x minus 5, x plus 1 over 2x. Now this is the whole thing over just one fraction right here. And this is the whole thing factored over a fraction. List all the factors of rational expressions in the table. So we're dealing with 5 minus 1 and 0. Economist estimates revenue and cost. The average profit is defined by the profit divided by x, where px is the profit function, determine the production levels that make where AP is above 0. Okay, so this is just understanding what the hell they're talking about. So fortunately, profit is always revenue minus cost. So remember that. Profit is always revenue minus cost. Now they give us the revenue. And they give us cost. So we're going to look at profit as minus x squared plus 6x minus 5. And then it's all going to be divided by x, because that's what they say APX is. It's going to be the profit of x, which is what we just figured out, divided by x. So if we factor the top, APX is, let's take a minus out, x squared minus 6x minus 5, which is plus 5. Oh, no, it's plus 5, yeah. So that's plus 5, minus 5, minus 1. All over x. So they just want to see, when is this above 0? You make a table. And then when you do this, and the points to look out at are 5, 1, and 0. So we look to the left of 0. Oh yeah, we've also got to include this minus 1. It's easy to forget that, but you have to include that as a minus no matter what. So we're always going to have a minus from the minus 1. Left of 0 would be minus 1, so we're talking about negative, negative, negative. And when I multiply all four things together, I get a positive. So that's above zero, everything below zero. But they're probably only concerned for production levels above zero, which they are. Yeah, no, it's based on number of snowboards, but I don't think you can have negative snowboards. So that's what left of zero would represent as negative snowboards. Oh, sorry. No, between 0 and 1 is 0.5. 0.5 here would produce a negative, 0.5 negative and positive, which means this would come out as negative, so that's not a valid range. Between 1 and 5, a good one to use is 2. 2 is negative, positive, positive, which will come out as a positive, so that's a good range. And above 5, let's take 6. That's positive, 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 which comes out as negative. So between 1 and 5 snowboards, and I think they represent in the thousands, so between 1,000 and 5,000 snowboards, APX, PX divided by X, which is APX, will be positive. So it's 1 smaller or equals, no, smaller than X, smaller than 5. In notation, it's 1 comma 5. Interval notation, which means between 1,000 and 5,000 snowboards, APX is bigger than 0. Just punch that into Desmos to see. And explain why the inequalities are equivalent. Okay. Oh, this is going to be hard, this left one, because you have to do two different solutions. Okay. To prove this is equivalent, we just got to make the first graph equal the second graph. And that just means putting this over the same denominator. So we've got to subtract from both sides. This. Okay. 0 now. And to put it over the same, we sort of have to cross multiply. This times this. And this times this. So on the left, we get x squared plus 3x plus 2 minus x squared minus x plus 3x plus 2x minus 3. So the x squareds cancel, and you're left with 3x minus 2x. You're left with x minus 1 all over x minus 1, x plus 2. So that's not what we wanted, so we're going to check our multiplication again. So if I expand x plus 2, I get x squared plus x plus 2x plus 2. And on the left, I get x squared minus x plus 2x plus 3x rather, minus 3. And then that becomes minus. This becomes minus. And this becomes plus. There we go. I had the wrong thing for 3. So the x squareds disappear. 3x just becomes x. And this becomes 5. So minor arithmetic error. And we can now see, oh yeah, and down below it's x plus 2, x minus 1. We can see it's the same fraction. How would you solve it? You punch it into the graphing calculator and you see when this graph is below that graph. Tables, you would use these as possible solutions, 1, minus 2, and minus 5, and see when it becomes, since it's supposed to be smaller than 0, when it becomes negative. Extend, that's a hard one because you have to do for both solutions when this is positive and when this is negative, because a negative solution, once it gets absolute valued, will be above or equal 1. So essentially, I think everything in here will become above or equal 1. Oh no, a few things will be small between 0 and 1. And then this, when is 1 over sine x smaller than 4? Okay. And then when is cos x over the bigger than 5? So I'm going to save those for next lesson. I'm just going to put this one up